Thank you guys for coming out here. I'm going to press on. The URL's relatively easy, malwaretrafficanalysis.net/2019/SharkFest. That will be there for as long as I have the website. So if you need to access the material again at some point, if you want to share the URL, please do. This, I believe, is being recorded, right? So it will be available on the SharkFest website as well. But the material should be there. I'm not going to go in too much about what I do, except that I work for Palo Alto Networks Unit 42. We're the public face of threat research for the company, and we're a very small team devoted exclusively to threat research and giving back to the community. So coming out and doing these sort of workshops, labs, and talks is one of our responsibilities. I also have the blog at Malware Traffic is my Twitter handle, if anybody wants to follow that, and be bored with a lot of really dry, dull, boring technical information. Knock yourselves out. Now, I like this crowd whenever I come to SharkFest because normally I'll speak at security-focused conferences. So when I do these sort of workshops, it really is geared towards people who are already in that mind frame of worrying about infections, right? Worried about malicious traffic. And when I come to SharkFest, I get a much different perspective where Wireshark is more about the network as opposed to anything malicious. So one of the feedbacks I got last year, I did a full-day workshop last year for SharkFest, was that, hey, everything was great, fine, we're going through this stuff, but when we started getting to the malware itself, I was a little lost. And that was because I was focusing just on the malware traffic, taking for granted that people knew how these machines were getting infected. So I do have, I still delve mostly in the PCAPs using Wireshark, but I take a little more time this year to explain why these things are happening and how these things are happening. But first we're going to start with Wireshark setup, because there's a certain way to set up Wireshark if you're dealing with Windows malware infection traffic that makes it much more advantageous for somebody to view a PCAP and review it quickly and be able to, based on your column display, get a very good idea of what's going on. And Wireshark by default tries to be all things to all people. And it certainly isn't really set up focused for to focus on, for example, Windows malware infection traffic. It's not that you can't find it using the default column display, but it is much easier to review and look at it using the method that I'll line up here in the Wireshark setup. And we'll talk about saving filter expressions, because there are definitely different filter expressions that we'll use to review PCAPs for Windows malware traffic. And then I'm going to do a quick little part on identifying hosts and users, because if you have an infected Windows host in your environment, right? I'm speaking from an enterprise perspective, not necessarily a home perspective. If your computer is infected at home, you probably know which one it is. But if you're in a corporate environment, if you're in an enterprise environment, and you get an alert on a particular IP address that was infected with Windows traffic, you got to be able to hunt that down. You have to find out where that computer is, because you do not want that infected Windows computer in your enterprise network, where possibly a Windows-based infection could move laterally. It could spread. So you want to be able to find that as soon as possible and take it offline, be able to fix it, especially if it's one of your enterprise laptops themselves. And then finally, the bulk of today's two-part lab will be dealt looking at PCAPs, dealt with looking at PCAPs and reviewing Windows-based malware infection traffic. Now, I do have some tutorials that I've published through the Palo Alto Networks blog and on my malwaretrafficanalysis.net website. So some of the stuff is also available on some tutorials, and the links to the Palo Alto Networks tutorials are there as well. Hopefully you guys all have these 16 PCAPs. Open up the first one. Open up the first one in Wireshark. Now, quick show of hands, is anybody familiar with my blog, and has anybody already altered their Wireshark column display? Okay, I know I got some hands saying people were familiar with the blog, but even some treasured fellow professionals that I work with do not alter their Wireshark column display, and it drives me nuts because they'll say, hey, look at this. And I'm thinking, well, yeah, I don't know. For example, you got the time, and it's the time in seconds since the first packet or first frame of this PCAP, and I can't, I don't know what time this is. All right, when I look at my Wireshark column display, I can tell exactly what time it is in UTC. I want to know when this stuff is happening. But it's the whole idea is it is not ideal, for me anyway, if I'm reviewing a PCAP that I know that has Windows malware infection traffic. Now this PCAP does not. This first PCAP does not. Quick show of hands, how many people are using a Windows environment? All right, now, word of warning, if you're using a Windows environment and you're looking at Wireshark with these PCAPs in a Windows environment, especially if it's Windows 10, Wireshark may, I'm sorry, not Wireshark, but Windows 10, the Windows Defender may actually either delete some of the PCAPs or delete some of the, we'll practice a couple of times extracting malware from the PCAPs. So just be aware that, yes, this does have some malicious material in the PCAPs. But as I mentioned, for me, as a threat researcher, for some of my fellow professionals who are threat analysts that are paid to research and review near real time what's going on, you got an alert in your enterprise environment. And you have to be able to track this stuff down and see, okay, was it infected or not? I got an alert. I got to look at the traffic if I've got access to the traffic. So one of the things I do here in this workshop is I also provide a full infection chain, or as much as I can, examples of stuff. Because in any decently protected Windows or corporate environment, any enterprise environment, you're not going to see a full infection chain because, for example, your web security gateway will probably block certain things before you could get infected. Your email filterings, because a lot of the stuff starts with malicious spam. Your email filters are going to block, 99% or more of these malicious emails that are coming in. It's still at scale for the criminals, right? It takes them a very low investment to be able to push out literally millions, hundreds of thousands, millions of emails periodically with malware or that lead to malware, right? And all you need is a very small percentage of this stuff to be able to infect a Windows computer. Now, so I'm filtering on http.request. This will give us the HTTP post request, the HTTP get request, HTTP head requests, all that stuff. And we're talking layer 7 here, right? But we're looking at the HTTP request, and with this particular setup, I can see part of the URL, but I don't have the domain name. I can see the IP address, but I don't have any idea who this is, just based on the IP, unless you're really familiar with some of this stuff, and you know that certain IP address spaces may equate to Google, for example. But we're going to have to change this. What do I want to see when I'm looking at a PCAP? I want to see the date and time in UTC. I want to see a source IP and a source port. I want to see a destination IP and a destination port. I want to see the HTTP host name for HTTP traffic. And for HTTPS traffic, I should see that server name. and then the info line so I could get the rest of the URL, for example, for HTTP traffic. How do I get there? I need to remove and add columns. I need to set the date and time to UTC date and time. I need to add custom columns. And I'm going to hide columns that I don't frequently use. And then Block, I always have a problem pronouncing his name. But one of our Wireshark developers, he told me this last year and I completely forgot it, but I was able to integrate it in today's lab, is combining column values. So we're going to have the same column that has the HTTP host name and the HTTPS server name in the same column, which is nice once you start filtering properly. Now, the first thing we're going to do using this first PCAP, and this first PCAP, by the way, is a Windows 10 host, just going to a single URL to look at an article from blog.eskill.com about the shortage of cybersecurity professionals in the industry today. And so you have that initial HTTP request, then you have all the other web traffic that supports the images, the scripts, the style sheets, and everything that supports displaying that page properly in a browser today. The first thing I want to do is I want to remove a column. Now, for me, that far left column to the left is the frame number column. The frame or packet number column, depending on what you have in your PCAP. I don't need that, right? And for me personally, there is no conceivable way that that will be useful for me for what I'm focusing on. So I will literally remove that column. Now you can hide it if you want. If you want to hide it, all you have to do is uncheck it. When you bring up, you right-click in the column header of the column that you want to remove, and then at the very bottom you select remove this column. Or if you still think you might need it, just uncheck the number column. But I get rid of the number column, and I also get rid of the protocol and the length columns. So you have a protocol there, and you should have a line. We're still filtered on http.request. And you'll have a protocol column that says HTTP, right? I already know it's HTTP. I appreciate that Wireshark tries to tell me whatever the particular protocol is for that frame or packet or TCP segment that's displayed up there. But I don't desire it on my Wireshark column display, so I get rid of it. The same thing for the length column, the length in bytes of that segment or packet or frame. That's not really important to me, so I get rid of it. Now you can hide it like we talked about, like I just talked about, or you can get rid of it. But when you do get rid of it, we should have time, source, destination, and info. So if you're following along with me right now, this is what we should have. Is anybody not able to get to that point yet? All right, so let's move on. So removing columns is easy. Hiding columns is easy, but adding columns is a little more involved. Right? So I want to add columns for the source port and destination port. And the easiest way to do, or the only way, I shouldn't say the only way to do that, the normal way to do that is to go to your column preferences menu and set that up. And the easiest way to get to your column preferences menu is just right-click in any of the column headers and select the fourth one down, column preferences. So please go to your column preferences menu. Right-click in any of the column headers. Go to column preferences, and you should come up with something like this menu. So everybody have this menu. we should see our 4 columns that we currently have. Now, a lot of times I'll change source and destination to just SRC and DST just to keep those labels a little small. But you're going to click this little plus button. And that plus button should give you a new column. The title is new column, and the type by default is always number. Now this is going to be our source port. So you're going to double left click, and where it says new column, and you're going to change that from new column to source port or SRC port. I prefer using abbreviations. Although on the slide it is not abbreviated. And once you get that source port typed out as the column title, you're going to double left click where it says number, and it will bring up a menu. Once you click on that, you should have a little arrow to the right. Just bring up the menu and scroll up or down, in this case down, until you find SRC EDDR, and I'm sorry, SRC port, and I want to see it unresolved. Now you could probably just use source port normally, but I want to use source port unresolved because I want that number. I don't want Wireshark telling me what it thinks that source port is. I don't want it to resolve it for me. I just want the number. I want that port number. So I select SRC port unresolved. And then you kind of got to click out of it. You got to click in that white area below just to kind of get out of that menu. Because what we're going to do is we're going to left click on it. We're going to hold down and drag it up just to right after source address. Now, as I'm going along through this is where some people have some problems. Is dragging it up there. Is anybody having any issues? And once again, you kind of got to click outside of it on the white space out of it. Left click before you left click on it. I usually click somewhere up around here and just kind of drag it up. Anybody having any issues dragging that up? Because when you get done, it should look like this. Now, we're going to do this again. Click that little plus button. We're going to do a new column. This is going to be our destination port or DST port. Once again, I'm going to change that from new column to destination port or dest port. I'm going to look for dest port unresolved. For the same reasons I look for source port unresolved, SRC port unresolved, I just want the number. I appreciate that Wireshark is able to do a lot of things for me, but I don't want it to resolve a particular port. I just want the number. Once you get that DEST port, kind of double left click underneath so you're out of that menu. And then we're going to, once again, left click and just drag it up to right under destination address. We should have something like this. Anybody having any issues getting to this point? If you do, please, if you're having any issues, please raise your hand. Because making sure we have our column display set up properly, or at least what I call proper, is key to reviewing, in my mind, to reviewing Windows malware infection traffic. So, ready to move on. Here we go. Now, and this is where I always tell people I'm a little anal retentive, a little anxious, a little anxiety. Things like the fact that the source port and the destination port are aligned to the right and everything else is aligned to the left, that just kind of bugs me. I can't sleep at night when I see stuff like this. This must be corrected. So you're going to right-click in the column that you want to align and then select Align Left for that source port and destination port column. And once you do that, now I can sleep better at night. Well, I've always had problems sleeping at night, but at least now this is not going to be one of the things that keeps me up. I have my time, source IP, source port, destination IP, destination port, and info. You also notice that I changed source to SRC and DST, but once again, the label is your particular preference. Next thing I want to do is change the time. I want to set that time to UTC date and time. So the easiest way to do that is go View, Time Display Format, and it's set at seconds since beginning of capture. Just click UTC date and time of day. UTC date and time of day. And now your time column should at the very least show you that your this PCAP was recorded on the 12th of January 2019. Everybody able to get this? Now the fidelity is down to the microsecond or picosecond or however long it is, but this is the default. I don't want the default. I just only need, for what I'm looking at, to the second. So once again, I'm going to go to View, Time Display Format, and change it from automatic to seconds. And now I'm even closer to where I want to be, and I can sleep even that much better at night. Anybody having any issues getting to this point? Now, for the HTTP host and the HTTPS host names, you cannot add those through the normal process of adding a column. But anything in the middle section, which is the frame details, you can find, literally apply any value as a column that you can find in there. Some of those are useful, some of those are not. But the most useful ones that I've found are the HTTP host names and the HTTPS server names. So, we're still on our first PCAP. We're still filtered on http.request. And just so we're all on the same page, we have left-click the very first TCP segment that's showing up there, that first packet, that first frame. That's what we have selected. And then we look in our frame details section, and then we expand the very bottom line where it says Hypertext Transfer Protocol. Little arrow down there, or a little triangle, I should say. Expand that, and you should find a line that says host :blog.eskill.com. Everybody able to find that? Anybody not able to find that? You're going to left-click on it to select it. You're going to right-click on it to bring up a menu, and then the third option down, I believe, is Apply as Column. Control-Shift-I. Thank you, sir. That would be definitely an easier way of doing that. Actually, Sake gave me some some cards that actually have some of the keyboard-based shortcuts. So I also have those up here as well. I got about 7 of them up here if anybody would like to grab a copy. But now we have a column that shows as host. And we have all those HTTP host names. So now, if I filter on http.request, which everybody should still be filtered on, you're going to see that column. Now, I've got a much better idea. I can see the full URL. So I get a better idea of the flow already of the unencrypted HTTP traffic for the web stuff. And all this is just regular web traffic. Now, host names for the HTTPS traffic, that's a little more, we got to dig a little deeper in that frame detail section to kind of work our way down to that. So let's do that. We're going to filter. If you're using the latest version of Wireshark, it's TLS.handshake.type equals 1. If you're using an older version of Wireshark, one of the 2.x series, and hopefully none of you guys in here are using anything older than like 2.2, Wireshark 2.2. So if you're on a Linux distro, on a VM or something, and you're using whatever that Linux distro has as Wireshark, it usually, right now for like Ubuntu or Debian, it's usually 2.6 point something. But if you try TLS.handshake.type equals 1, and you can use EQ instead of the double equal sign. If you try that and it doesn't work, try SSL. If you try SSL.handshake.type equals 1 and your filter bar turns yellow, then try TLS. But your filter bar should be green when you do this. And I don't know if you can tell. This is supposed to be kind of like a purplish lavender color as a background. So everything should be purple and lavender-ish, and your info column should say client hello. Is everybody able to get this? Anybody not able to get this? So now, we've got where we should be able to find in the frame details, we should be able to find that HTTPS server name, that domain name that was used in this URL that went over HTTPS. So we can't see the URL, but we can at least see the domain name. So we're selected on the very first frame packet segment of the results up top in the column display. And we are going to expand transport layer security, that very bottom line. If you're on Wireshark 2.x, it should say whatever SSL is spelled out. And then you're going to, underneath that should be a single line that says TLS v1.2 record layer, handshake protocol client hello. You're going to expand that. Handshake protocol client hello. Does anybody not see that? Expand that. When you expand that handshake protocol client hello, you'll have a lot more information. You're going to have to scroll down a little bit. So under handshake protocol client hello, there should be a line that says extension server name, with a length of, in parentheses, it'll say length 20 characters. Anybody not able to find that?
Is that extension or just server name?
The line itself will say extension : space server _ name.
Oh, okay.
And then it will have in parentheses len equals 20. Able to find that? That you'll have to expand. Underneath that, you should see a line that says server name, indication, extension. Anybody not able to find that server name, indication, extension? So you're going to expand that, and under that server name, indication, extension should be a line that says, and I'm going to unplug. This should be a line that says server name www.gstatic.com. Anybody not able to find where it says server name : space www.gstatic.com? Show of hands if anybody is not able to find that. Don't be shy. If you found that, good. That's our HTTPS server name for that TCP segment. You go back real quick. I think we all got it, right? We expanded handshake protocol client colo. We worked our way down to extension server name. And then we expanded that and we found gstatic.com, www.gstatic.com. Left click on that to select it, right click to bring up a menu, apply as column. When you do that, now you have a column that says server name, just to the right of the column for our HTTP host names. Everybody able to see this? Okay, now I want to combine those two columns. I want to combine, so when I filter for HTTP and HTTPS traffic, I'll see them all in one column instead of two columns right beside each other. So we're going to right-click on our column headers, and we're going to go to column I'm sorry. Let me rephrase that. I forgot. We're going to hide columns we don't frequently use. I don't frequently use. So when I'm looking at web traffic and I'm filtering, for example, for http.request or tls.handshake.type equals 1, the source IP, I'm pulling on just a single Windows client. And that single Windows client will always be the source IP. When I'm testing a host, when I'm testing malware in my lab, I always have the same source IP or the IP for that internal Windows client. It's always going to be a non-routable IP address, Class A, Class B, Class C for the IPv4. So I'm going to hide that source column. I'm basically going to right-click and uncheck source for the source address. And I'm also going to uncheck source port for the source port. And now, I've got the columns set up exactly like I want them when I'm reviewing web traffic. Not exactly like I like them, but almost there. I've got that time, destination IP, destination port, HTTP hostname, HTTPS server name, and info. Now, I can combine the HTTP hostname and the HTTP server name to the same column. So I'm going to right-click in any of the column headers, go to the column preferences menu. So we're going to change this, the host column. But what I'm going to do is I'm going to go to the I'm going to basically add this. I'm going to do http.host space or, and then double click in here to kind of copy and paste that up there. So we can double click in any of these columns and double left click to get in there and select the value. So I want to do this value or this value, and you can make it whatever you want. You can put it in whatever column you want, but I put it in the host column because that's, to me, that's the host name. You can put it, if you want, in the server name column. It'll be this value or this value in the same field, right? HTTP host or tls.handshake.extensions_server_name. And I put it in the host column. Is anybody not able to do that? We should be able to double left click in those fields and change it. So we should, so I got rid of that server, the server name column. I just have both those values in the host column. Anybody not able to get this? because this is what we're going to use, this column setup is what we're going to use for the rest of today's lab. Yes, you need both of them. You need the one value space or the other value. And if you want to, the title, you can name the title whatever you want. I name it host. But if you want to, feel free to change that column name to whatever you want.
Do you want it to, if it's not in the HTTP header, do you want it to resolve the host name? Like this column is pulling from the HTTP header, right?
I believe so. This http.host.
Right. So do you want the rest of them to be pulling from DNS? So you can get a full idea of what they want.
It's not pulling from DNS to get that.
Not for that.
Right. So this is literally taking whatever it's finding in the HTTP traffic for the HTTP host name. The same thing for the HTTPS server name. So in this particular case, there's no DNS involved in grabbing those values to display them as a column. Now, we're going to look at filter expressions. So here's the normal, what you would think would be normal as far as looking at web traffic. I can filter on http.request or tls.handshake.type equals 1. And in this first PCAP, I can get a good idea of the flow of web traffic now. Much, much better than if I use the default Wireshark display, column display. Does that make sense to everybody here? Are you all with me? Now, the one thing I will say is if you scroll down every once in a while, you'll see a baby blue line that says port 1900. This is UDP port 1900. It's HTTP traffic over UDP port 1900. And it's always going to 239.255.255.250. 1900, and you get a m-search. This is SSDP traffic, a Simple Service Discovery Protocol. It's caused by Google Chrome. I have Google Chrome installed on this machine. I'm not using Google Chrome. I just have it installed, and Google Chrome generates this traffic. So I'm going to filter it out. My basic web filter, as shown up there, is I use what we just saw there, but I omit any SSDP traffic. I'm not saying that SSDP traffic can't be malicious, but in the normal course of events, I don't see anything malicious over SSDP. I see a lot of SSDP on anything that I have Google Chrome installed. And how many people are not paranoid enough of Google to not run or at least have Google Chrome installed? Anybody paranoid of Google Chrome and would rather not use Chrome? Because thank you, sir. We're brothers in arms. Normally I don't use it, but I'm kind of forced to use it now for work. But this will be our basic filter, that very first one. Now, you see the basic plus. It's my basic filter plus, or tcp.flags equals 0x000. There should be a third 0 there. I apologize. 000. Instead of 2 zeros, there should be a third 0. That's the send flag. Now, you would think in Wireshark, I should be able to use tcp.flags.send and get only send packets. Only TCP segments that have the send flag set. But for some reason, that hasn't worked for me. I'll filter on tcp.flags.send, and I'll get a bunch of other stuff that is not just TCP segments with the send flag set. So I have to use this backmasking technique. Equals 1? That will work? Well, thank you. And this is another reason why I like coming to SharkFest, is because there are people who are able to show me better ways of doing what I have been doing for, in some cases like this, quite some time now.
But he's only asking for the send. If you do send equal 1, you'll get the SYNAC facts too.
We'll get the SYNAC.
You do it without the equal
that has a SYN flag, right? If I do this with 3 zeros instead of 2 zeros, it will only give me the SYN segments, right? So I will get a good idea when I do this if there's any non-HTTP traffic, there are any TCP connections that are attempted at least. Because every TCP stream starts with a SYN flag, with a segment that has a SYN flag. So my basic plus is I'm trying to get basic web traffic plus anything that has any TCP connections that include that are not HTTP traffic. Yes, sir.
Just to clarify on that TCP.flags.syn, the meaning of that by itself is that has the dissector put a TCP.flags.syn field into the tree.
Ah.
If you want to check for the actual value, then you've got to say, is it equal to 1 or is it equal to 0?
Ah, gotcha. Okay, so that TCP.syn is literally anything that's been tagged as SYN by the by Wireshark. Okay, well, hopefully, please, if you guys haven't done this yet, please filter on just basic. Have that in your Wireshark filter. And what we're going to do is we're going to add this as a filter expression. I call them buttons, but they're actually labels. So I'm going to save this as my basic filter. I'm going to click that plus sign at the far right of our filter bar. The label, whatever they have in there as a default, I'm going to change it to basic. Our filter value should be the same thing as the filter here for this label. And then once I name that basic, I'm going to click OK. You can add a comment if you want, but I don't currently add comments. And when you save that as basic, you should have a label to the very right of your filter bar that says basic. This is our basic web filter. This is the first thing that I check when I look at any Windows malware traffic that I've generated. So has anybody not got their basic filter set up yet? Now please do the same thing for Basic Plus and Basic Plus DNS. And just real quickly, I'm going to correct that because that bugs me. So I'll give you guys a minute or two to do that. Now I've done this often enough. Lord knows I wipe and set up new hosts, and I've gotten to the point where I can do this in my sleep, where I set this up. So these three filters, this basic, basic plus, and basic plus DNS, they're going to be the ones that we will use as we examine PCAPs of Windows malware infection traffic today. And when you get done, you should have 3 buttons. Now, I'm going to move on in case some people are a little slower trying to catch up with this stuff. We've got the PDF file, or you should have access to the PDF file that has all these slides. So let's move on. One of the things I want to talk about before we move on, though, is the configuration profiles. If you go to Edit Configuration Profiles, what we've been working on has been our default Wireshark configuration for the column display. And if you click on Edit Configuration Profiles, you make your way, this should show the Configuration Profiles menu. It will have your directory. In this case, I'm using Debian And I've got Wireshark set up on Debian. This one's actually Wireshark 3.0, but it's on the default profile. What you could do is if you wanted to make a copy of that, you can hit this little double square-looking button and then copy that over and then rename it to something. If you wanted to actually save your configuration profile, find that file in the directory that it has there, and you can copy that over to another version of Wireshark. I've asked the developer den if they would do an export and import function for configuration profiles. And I got some positive feedback on that, and it looks like hopefully they'll implement that. And then when I do future workshops, I could just say, hey, import this configuration profile, and I don't have to spend 30, 45 minutes doing this to get everybody up to date on how I want it to look. But this is still good because this shows you guys a bit more about Wireshark than you may not have already known to this point. And before we move on to the Windows malware traffic, let's look at identifying hosts and users. We're still on the first PCAP. To identify hosts and users, we can look at DHCP traffic, which is kind of rare. Normally DHCP lease renews every 8 hours or a week if you're a LAN-connected host. And then we could use NetBIOS name service traffic to identify the host name of a Windows machine. And then we could also, if this is in an Active Directory environment with a domain controller, we can not only get the host name, we could get the Windows user account name, which in my case, for my exercises that I always post online, it's always first name dot last name. But in many enterprise environments, they may not follow that naming scheme. There was one place I worked at where the Windows user account name was the first 4 letters of your last name and then 4 random numbers. But let's filter on DHCP on that very first PCAP. So you're either going to filter on DHCP if you're using an older version of Wireshark, older than, you're using 2.x, you'll have to filter on boot P. But you're going to expand this very last line. You're going to scroll down to where it says host name, right? Now keep in mind that when we filter on DHCP traffic, we've got the packet that we're going to look at is going to be the one from the Windows host as it requests either an IP address for the initial DHCP lease or it renews its lease. But either way, the packet that we're looking at that has the host name for that host, the source IP is always going to be for that Windows host. In this case, 192.168.1.103. And when we scroll down, when we expand that, we find that host name line, we look, we see a host name that says finance-8F25-PC. Is anybody not able to find this? So filter on DHCP or boot P if you're using an older version of Wireshark, expand that very bottom line in the frame details, scroll down till you find option host name, expand that, and you should have your host name. This has got to be in the very first packet of your results. Now, DHCP traffic is not as frequent as NetBIOS name service traffic, NBNS traffic. So if you want to get a host name, the quickest way that I found of getting a host name for traffic on a Windows host is just filtering in Wireshark on NBNS. And in this first PCAP, if you filter on NBNS, everything should be yellow. And you'll see what you're looking for is either refresh NB or register NB. And in this case, you're only going to see refresh NB in this particular PCAP. Well, you want to look for refresh NB in your info column or registration NB. And that will give you both the host names of the Windows host involved, and it will give you, if there's a domain controller, it will give you the name of that domain, NetBIOS-wise. And if it's not, there's no domain, if you got like a home computer set up, your default name will be workgroup. Now you see all these other name queries here with the random alphabetical characters? Anybody know what that is? I'm sure somebody has an idea. That is caused by Google Chrome. So what Google Chrome does, when you open up Google Chrome, it does DNS requests for strings of alphabetic characters. No actual TLD, no top-level domain. It'll just do a DNS query. It will generate a DNS query for a random string of alphabetic characters. Now, Windows is not able to resolve that. I'm sorry, DNS is not able to resolve that. So in a Windows host, if you can't find that particular host name through DNS, it's going to try doing it through NetBIOS, name service traffic. So if you actually filtered on DNS, you would see these same queries before they come up in NBNS traffic. Does that make sense to everybody? If you're curious, filter on DNS, look through all the DNS traffic there. You should see these names in your DNS traffic. Do you not, sir? Why does it do that? Somebody, I've taught this workshop, this lab several times. Every once in a while somebody is able to tell me why Google Chrome does that, and then I always forget, like the very next day. Because I'm like, oh, I think it's looking for proxies or something like that.
I never see that. I see WPAD a lot, but I never see that.
There's WPAD and ISOTAP, which is another default Windows configuration issue that generates that traffic. Now, if I didn't want to look at these extra queries for names in NetBIOS name service traffic, I could filter on this, and that would only give me the refresh NB and the registration NB lines if I wanted to do it that way. But I'm not going to worry about this. I'm just showing this here, giving this information to you in case you wanted to use that filter. And it is, this will be available in the PDF file with the other PCAPs. And I'm not going to, on this first PCAP, I'm not going to use the Kerberos.cname string filter. We'll do that in our next PCAP. When we actually start, finally, looking at Windows malware traffic. So a couple of words about Windows malware traffic. Malicious spam is the most common method for mass distribution of Windows malware. You're trying to reach clients with this, not servers, but clients. Servers, they get their own special attacks. People are like pounding them all the time, trying to find, trying to get in through RDP, for example, or SSH, or some Apache Struts vulnerability or something like that. So servers are getting attacked. Clients are not directly getting attacked. You kind of have to go at it indirectly. So email, as I mentioned earlier, is so cost effective for criminals to send out hundreds of thousands or millions of emails periodically, so low of a cost to them that they could do that and have a very, very small successful rate, and it somehow still is profitable. Now, there are other ways of mass distribution of commodity malware that everybody sees, not targeted attacks. But normally it's through malspam. That's how I get my examples. So the malspam either has some type of attachment, or it's got a link to an executable file or some installer that is then saved to the local host and run on that local host. So for our second PCAP, we're in an Active Directory environment. We're going to use that Kerberos.cname string filter at some point to figure out who this is. But somebody got infected on pizzajukebox.com within that network in 10.0.40.0. Now, here's, I was talking with one of the developers, Christian, last year, and because my presentation last year was focused on, okay, we got these alerts, here's how you find them. We got these alerts, here's how you find them in Wireshark. And he was saying, hey, you know, most of our people, the people coming to SharkFest that are taking this class, they aren't necessarily looking at this from an enterprise environment angle. Right? He was telling me that, so for example, he would get a PCAP from somebody that says, I think something is wrong with my Windows machine. You know, I recorded the traffic, can you take a look at it? So there were no alerts involved. But, so I thought about that. I thought about that a lot. And it's like, okay, how do I, you know, kind of change the tone for a mostly non-security audience? And the thing is, I can't really do that, right? If you get infected, if your home PC gets infected with an information stealer, you're not going to know. It's only when you start seeing things that degrade your system performance, and a lot of these information stealers are, a good deal of them are just smash and grab, right? They'll get on your computer, they'll steal your information, send it somewhere, and then they'll delete themselves. And then you have no idea that you've just been compromised. You know, that your Windows client has had, you know, the browser's caches have been scraped. If you keep your passwords stored in your browser, right? Loki Bot, in this case, Loki Bot is one that remains persistent in an infected Windows host. So it will, even if you reboot, sets up a Windows registry entry so it keeps itself alive. But in this case, we don't really have too much traffic. We only have traffic on the command and control, the post-infection traffic that Loki Bot generates after it infects your Windows host. And in this case, what I have is here I'm using Security Onion. Is anybody familiar with Security Onion? Okay, I got it 1, 2, 3 hands, 4, 5, 6. So Security Onion is a Linux distro set up for network security monitoring. Right? So I'm using this for Security Onion. I've got it set up with Suricata as the IDS, and I'm using, in this case, the Emerging Threats Open Rule Set, a completely free rule set. So if you were so inclined, you could get Security Onion, set it up, get that, you know, with Suricata and the Emerging Threats Open Rule Set, and then you can use TCP Replay to get that PCAP and literally generate these alerts. But for the sake of argument here, for our first few PCAPs that we're going to review, let's look at it from an enterprise aspect, where you've got networks being monitored for suspicious traffic. And then occasionally you'll get alerts like these that you would have to investigate. So in this case, if you investigated it, you'd find the following. Open up your second PCAP, SF19US MTA Lab 02. Filter on your basic filter. We're looking at, in this case, Loki Bot only generates regular HTTP traffic. That's how it exfiltrates data. So our second PCAP. And if anybody needs a USB key, well, please do, because you will be bored to tears without the material. Anybody else? Here you go, sir. Pass those USB keys around. If anybody is still without the PCAPs that we're covering here today, please look around. If you get done with your USB key, kind of hold it up for other people to see so they can get a copy of it. And this will be online. I'll have the URL at the end of this lab. So this second PCAP, we have alerts on this IP, right? This destination IP is straight from the alerts. And they're saying this is all Loki Bot. And we got some weird .cf domain, which is, you know, I'm not saying that any TLD using .cf is bad, but any of the ones I've seen have certainly been a little odd, usually associated with some suspicious or malicious activity. And these are posts, and what is it, post-sino/free.php. So this doesn't really tell us anything just by looking at the Wireshark column display, other than we're able to confirm that the IP address matches the same IP address of the alerts. So what we need to do is we need to follow one of these TCP streams. So select that very first HTTP post request in your frame results up in your column display. Make sure you got that selected. Right-click to bring up a menu, and then follow TCP stream. Left-click to select it, right-click to bring up a menu, and then follow TCP stream. You should see something like this. Now, all the HTTP responses to this say 404 not found when you look at those HTTP response headers. But one of the interesting things here is you look at the HTTP request headers, you'll see a user agent that says Mozilla/4.08 Charon Inferno. Now, normal HTTP user agents will give you an indication of the operating system in the browser. So Internet Explorer 11, for example, has a particular user agent line that's specific to Internet Explorer 11, Google Chrome, Microsoft Edge, Apple Safari. They've got distinct user agent lines that you can tell that, you know, this is Chrome, or this is Firefox, or this is Edge, if anybody actually uses Microsoft Edge. But this user agent is unique to Loki Bot. I can tell you this right now because I know I've looked at this often enough. Right? If you're looking at this and you're like I was when I started out, and you're asking, why does this do that? Why is this malicious? Why is this not malicious? You don't have anybody to tell you. You eventually just got to work up that information yourself. So, you know, at some point I realized that, hey, I started looking at those signatures where I could look at the PCRE, the criteria that it looks for. And one of those alerts specifically looks for this user agent in the HTTP header. And I don't know if this is a legitimate user agent. The fact that it says Mozilla/4.08 indicates to me that even if it was a legitimate user agent at some time, I don't think it is anymore. I mean, literally. And then look at this. Look at the data it's posting in red, or whatever you call this color, reddish orange. You see something that looks like Alice O'Brien. You see Hamburg 1792-PC, and you see Pizza Jukebox. Now, I already told you that our domain is pizzajukebox.com. The domain controller is that domain in NetBIOS, you know, as far as Microsoft is concerned, is just Pizza Jukebox internal to the network. So what happens here is you literally have the Windows user account name, and then Hamburg 1792PC for the Windows host name. So just by looking at this traffic, yes, sir? Yes. Now that ccav.ru, that I see every single time. But there is a particular pattern to this. If you see this stuff often enough, if you're fortunate, you know, enough to be able to cobble together equipment to have a lab in your own home to actually say, okay, you know, I'm going to infect this Windows PC and be able to record it and see what happens, then you see enough of this stuff. This is remarkably consistent for Loki Bot. The traffic always looks like this. There's always that ccav.ru, as you were saying, sir, right? There's always this user agent. And there's always the Windows user account name, and then the host name, and then where it says Pizza Jukebox, I can tell that this is an Active Directory environment with a domain controller. Otherwise, I think it just does the host name again.
Is that last red line a hash password?
I'm not sure. That one I haven't been able to figure out what that is. It could be the machine GUID. But it definitely is, this I believe is information checking off. And normally I would associate something like that with a machine GUID or some other GUID within that Microsoft host. And it always says 404 not found, possibly as a way to convince people that, hey, no connection was actually done here, but guess what? Loki Bot traffic always generates that. So the server that is collecting this information that's being HTTP posted from that host, from that infected Windows host, it's always going to say, hey, you didn't find this server, but it actually gets the information. Yes, sir. CCAV.ru, is that Kaspersky antivirus? I don't know if that is supposed to represent that or not. I can tell you that this Windows host doesn't have any antivirus on it when I test it in a lab environment. So it may very well be associated with that. I couldn't tell you, sir. Now, that really is all there is to this particular PCAP as far as the infection traffic. You've got those HTTP post requests, and those are all associated with Loki Bot. It's a very simple, straightforward infection. There's nothing really complicated about this. It will just keep doing those posts every minute or two. It's not exactly quiet or subtle or sneaky on a network. But if this got infected, we already saw what I told you at least was the Windows user account name and host name. And we can find this through Kerberos authentication traffic. So if you'd be so kind as to, on that second PCAP that we're still on, filter on Kerberos.cname string. It's case sensitive. And what we're going to do is we're going to find that Kerberos CNAME string value. We're going to apply that as a column. We'll keep that column hidden because we really only need that Kerberos CNAME string column only when we're trying to identify a particular host that is using Kerberos, like a Windows Active Directory environment. So, filter on Kerberos.cname string. We're going to select that very first frame that's listed in the column display. Make sure you're selected on that. Left click on that. Go down to where it says transmission protocol. I'm sorry, where it says Kerberos. That should be your bottom line. You expand Kerberos. You expand AS-REQ. You expand REQ-body. Then we continue to work our way down. Under REQ-body, there is CNAME. Under CNAME is CNAME string. And that very first TCP segment, the CNAME string should show as Hamburg 1792-PC, or -1792-PC with a $sign at the end of it. Anybody not able to find this? So what you're going to do on that line where it says Hamburg 1792 PC, you're going to left click on to select it. You're going to right click to bring up a menu, apply as column. Left click on it to select it, right click to bring up a menu and apply as column. And now we have a CNAME string column. If you scroll to the very bottom, I don't even think you have to scroll on this one. This is a relatively short PCAP. We see the host name up here. The host names, the Windows host names in Kerberos traffic, this authentication traffic, always end with a $sign. And the Windows user account names in this sort of authentication traffic that we see to the domain controller back and forth, the Windows user account names do not have a $sign. So now we can confirm, okay, Alice.O'Brien is the Windows user account name. Fortunately, this fictional company that I just invented here, pizzajukebox.com, they use first name dot last name as their Windows user account name. Now we can track down Alice, and we can say, hey, that Windows PC that you have in Hamburg is infected. We need to wipe it. We need to fix it. So if you guys would all be so kind, if anybody not able to get this yet, if you've got it, right-click on that column and just hide it for now, because we're not going to use it for the rest of this lab. But now you've got a CNAME string column in the in the event that you have traffic from a Windows client in a Active Directory environment, then you can find out some more information about that client. All right, we're up to our third PCAP. If anybody's walked in, so we've gone through the first two PCAPs, there are USB keys floating around that have the training material on this. So we're on our third PCAP. Open up that third PCAP in Wireshark. Now this is, there's no domain, this is just a home computer, 10.4.22.0. It's somewhere within that last octet, that network segment. Now, this is Azorult. This is what I refer to as smash and grab as far as an information stealer. This is one of those that gets delivered to a Windows host somehow through email or through exploit kits over the just casual web browsing. You can get on your computer, and it will collect all the information that it can about your host and any passwords that are cached anywhere on your host, and it will send it out. It will do 2 HTTP post requests, then deletes itself. So in this case, this particular infection, what I did in my lab host is I found an email that had a malicious attachment. This attachment is a rich text file, but it is not a real document. It takes advantage of it. It exploits a vulnerability that was categorized in 2017, almost 2 years ago, and we still see examples of this on a daily basis, multiple examples in Wireshark. So this is still being sent out there as we speak. So there's got to be some money in this for the criminals if they keep doing this. But it will use a .doc file extension, so it will open up in Microsoft Word a vulnerable version of Microsoft Office that has not been patched, is not up to date. It will just immediately upon opening the document, it will generate an HTTP request to a web server somewhere to retrieve a Windows executable, which is the Azorult malware binary, and it will run it on the host. Usually, it's in the user's app data local temp directory on a Windows host. Because normally, by default, even if you're in an Active Directory environment, you still have executable privileges as a user in that directory. Here is an example of the email. I got this email from Virus Total Intelligence. I'm fortunate enough to have access to VT Intel. Does anybody here have access to it? It's pretty expensive, apparently. I know that whenever you go to Virus Total Intelligence and look for access, it says, well, you want a trial period? And then apparently it is so expensive that I've never seen anybody pay for it on their own. It's always through your employer, if you get it. And I'm just fortunate enough to get it. So anything submitted to Virus Total, like for example, this email, I'm able to retrieve a copy of it. This was from last month. I'm sorry, not last month, 2 months ago. Month and a half ago. So normal people, they're going to say, oh, I got an email about 22,000 metric tons of steel billets, and there's a document there. What's the harm if I open it and check it? It's obviously not to me. In fact, usually these things, they will keep they'll go out to multiple recipients, and you won't see a to line in the email headers visibly in your email client. So this is what this looked like when I opened it in Mozilla Thunderbird. But you have an attachment, right? This says vessel particulars.doc. This is the rich text file. And it's going to show as a Word document in Microsoft Windows. When you open it, and I was using Office 2007 unpatched on Windows 7 host, Service Pack 1 unpatched, and I open it, and it shows that it's converting, right? As it's doing this, it's doing the malicious activity in the background where it goes to that web server and grabs that Windows malware binary. after the infection has already started, may even be finished, you open it up and it looks like a bunch of hex characters, right? I've got what says 15 of 16 pages, 516 very long words. All it looks like to the average viewer, to the average user, is just a bunch of gibberish or garbage. And you think, if you don't know any better, you're thinking, oh, okay, well, this is a corrupt document or something. I'll just close it and move on with my day. Meanwhile, if you have somebody actually monitoring the network traffic, they may see alerts that indicate that Azorult, this information stealer, was active on your network. If you're on a home computer, you're probably just screwed. It's got your stuff. Once again, this is smash and grab. This malware will delete itself after it sends the information out to whatever server it's got set up. Now, the alerts on this one are all to a particular IP address. And when we open up that third PCAP in Wireshark and we filter on our basic filter, we see an HTTPS URL over Bitly. We don't know what it is. It's HTTPS traffic. We see an HTTP request, the support service.site for get/sug.pos. And then we see 2 HTTP post requests to the same IP address that we saw in those alerts. So according to the alerts, these HTTP post requests to azaman222.xyz are already identified as Azorult, if I can trust the alerts. Normally, you would have somebody investigate it and be able to somehow confirm that, yes, this is Azorult, if you're in an enterprise environment, right? I don't know anything about this Bitly URL. Bitly's a legitimate service, so I can't find anything about that. But what about this support service.site that get sug.pos? Left-click on that particular frame for support service.site, follow that TCP stream for that HTTP request to support service.site. Select that, follow the TCP stream. Now, this is one of the first things that I learned when I started out as an analyst looking at this stuff, is how to recognize, to follow TCP stream and recognize a Windows executable or DLL file, right? I'm seeing some head nods here, right? This is one of the first things that you learn when you use Wireshark. If you're looking at, it doesn't even have to be malicious traffic. Well, here's what we have, right? The first 2 bytes of any Windows exe or DLL file always show up as the ASCII characters MZ. And then you'll, I want to say 95 times out of 100, in the cases that I've seen, there will always be something that says this program must be run under Win32. This program cannot be run in DOS mode. This program something. Now, another thing that, if you take a closer look at this particular TCP stream, you look at the user agent, right? And that user agent is an old user agent string that I think at one time was legitimately used in Microsoft Windows host. I don't know if it was Internet Explorer 7, but you see MSIE 7.0. And you see some other older versions of .NET. But what I'm seeing here, the fact that it says MSIE 7.0, this is not a normal user agent string. This is not something that you see in legitimate Windows traffic or anything that I see. Has anybody seen this HTTP user agent string in legitimate traffic? You may not. You may not have, at this point, if you're just starting out looking at this stuff, you may not realize this, but this is not legitimate. The fact that the HTTP response headers from the server that return this Windows executable file is saying the content type is text/plain. It is not plain text. right? It should say, at the very least, it should say application/octet-stream. Then it was like, okay, you know, I can believe that it is what you're saying it is. Or sometimes you'll see like a MS-DOS executable or something along those lines. But here it's trying to tell you that this is plain text. It is not plain text. And this is common, that we'll see servers hosting Windows malware, these malicious executable files. This is a common tactic. They'll say, oh, this is HTML, and they send you a Windows executable file. Or, oh, this is an image. This is a PNG image, and they're sending you a Windows executable file. That's wrong, my friends. That is wrong. And if you see that, that's an indicator. That's an indicator that you've got some strange goings on. Malware frequently does this, right? And this was caused by that rich text file that was attached to that email that we just saw earlier. Now we can extract this Windows executable file from the PCAP. So if you go to File, Export Objects, HTTP. Now, what I will say is, if you do this on a Windows host, and this is already a couple of months old malware, Windows Defender will probably delete it. So a show of hands, well, first let's go through extracting this. So File, Export Objects, HTTP. It brings up the Export HTTP Objects list. It's going to be the second one down. It's the one where the file name says sug.pos. So even if your Windows computer doesn't automatically delete this, you're not going to be able to accidentally double-click it and run it because it's got a .pos as a file extension. It shouldn't do anything, I don't think. But just to be on the safe side, don't double-click it. Now, a show of hands, if anybody's on a Windows host and they tried exporting this Windows executable file from the PCAP, has your antivirus already deleted it yet? I got a couple of show of hands. Now, this is why I always say if you've got any real interest in doing this for a living, to actually investigate this sort of stuff, you need a non-Windows environment. Or I should say, I say you need it. I highly recommend a non-Windows environment. You know, use a MacBook if you got money. Use Linux if you don't. But I prefer Debian myself. But I've had some experience using the Red Hat CentOS varieties. I haven't really messed around with Arch Linux or some of the other distros out there. I prefer Debian or even Ubuntu. But, you know, you could easily get that stuff for free, and you can get Wireshark, and you can do this, and it won't automatically delete your malware. And if you're on a non-Windows environment, and you've got command line access, if you've got a Nix variety command line interface, you pull up a terminal window, you do a file command on that sug.pos file, and you can confirm that that is a Windows executable file, right? And then you can do a SHA-SUM command to get the SHA-256 hash of that. Now, why wouldn't I want to just submit this to VirusTotal and let VirusTotal take care of all that for me? Anybody? Why wouldn't I just submit this to VirusTotal? Right. If this was a targeted attack, right? If I don't know anything about this Windows executable file, and this is a targeted attack, yeah, you can be sure that the attackers are monitoring VirusTotal to see if somebody found their piece of malware that they're trying to infiltrate your network with, right? In this case, this is commodity malware. This stuff is really only good for about a week at the most before and they're literally generating new viruses, new samples of Azorult every single day. But I can check that against VirusTotal. If you actually check that file hash, or even if you submit the file to VirusTotal, you'll see that it's malware. And just for the sake of argument, let's follow one of the HTTP post requests. Follow the TCP stream for one of the HTTP post requests. So left click to select one of those HTTP post requests, right click to bring up a menu, and follow TCP stream. And if you look, this is what an example. Yeah, I think this is the second HTTP request. They're both on separate TCP streams. This HTTP post request to azaman222.xyz. .xyz and some of those janky domain, top-level domain names, I've never seen anything good come out of .xyz. I'm sure there are legitimate websites using .xyz as a domain name. I haven't personally run across them. Maybe that just means I'm looking at too much malware. But you notice how the characters kind of repeat. There's a pattern there, right? It may not be immediately apparent, but I'm seeing the parenthesis 9 dot, parenthesis 9 dot, parenthesis 9 dot. And kind of, there's a look to it, which people have figured out to do snort-based network-style alerts to using snort or suricata, or, those types of. There's a Perl-compatible regular expression that you could look at that has been developed to catch this style of traffic. And look at the user agent. This user agent string shows MSIE 6.0b. Right? It shows Windows NT 5.1. If you look up what Windows NT 5.1 is, I believe Windows NT 5.1 is like Windows XP. Service Pack 1 or without the Service Pack. But this is not a normal user agent line in HTTP request headers. Yes, sir?
And also it changed from the first GET request. Most browsers don't change their user agent.
Are you talking about the first post request to Azaman? I'll have to double check that. Thank you. Yeah. Like you said, that's another thing. That's another thing I didn't even think to talk about for this particular one, is that the HTTP post request, the first one, has a different user agent string. What is a user agent string for that first one, say? Do you remember?
Like MSIE 7.0 and Windows NT 6.1.
Ah, gotcha. I think that may have been the HTTP request for the GET request for the Windows executable file. I want to say the HTTP post requests for the two of them should have the same user agent in this case.
Right, but I guess, if the GET request normally come from the same user agent.
You're right. We're talking about normal routine web browsing traffic, right? So yeah, it should have the same user request. You're right. I'm sorry. I misunderstood you, sir. So the fact that you've got that GET request that has one specific user agent that's markedly different from this. Now, what I will say is the HTTP post request that I've seen for Azorult have always used this particular user agent string, which is another identifier. So we have hit 3 o'clock. We'll take a 15-minute break, and then we'll start in on, hopefully, some more interesting malware, and we'll look at some stuff that's not just information stealers.